welcome in a new video. In this video, we are going to analyze the algorithm which we discussed in our previous videos. Okay, algorithm is like SGF, FCFS, or all the algorithm which we basically discuss. Now we are going to analyze this algorithm. Okay, so first of all, what is the okay? So the main thing is we analyze algorithm. We basically see two things. First of all, the basis of an algorithm, and the second thing is the algorithm which is suited for that particular basis. Okay, first one is the first base is of an algorithm is that minimum average waiting time among the all non-preemptive algorithm. Minimum average waiting time among all non-preemptive algorithms. So name that algorithm which gives us a minimum average waiting time among the non-preemptive algorithm. Non-preemptive algorithm like FCFS, SJF, SJF, LJF, or whatever the all non-preemptive scheduling algorithm is, HRRN, whatever. Which algorithm will give us a minimum average waiting time? So, if you discuss my video of SJF, then you simply get an answer that the answer of this basis is SJF. SJF is a non-preemptive scheduling algorithm which gives us a minimum average waiting time. Okay, so let's see this as well. Like in SGF, what basically happened is the process is having like P1, P2, P3. Let's say we have three processes, 1, 2, and 3. So what happened in SGF is those we select those processes who have a minimum burst time. Okay, so P1 come and they execute, then P2 execute, then P3 execute. So whosoever have a smallest burst time will execute. Means in a simple way, processes come in a CPU, come in a ready queue, get a CPU, execute, and then terminate. It's the switching between the processes is continuously going on. The CPU is not become an ideal. If the CPU not become an ideal, it means processes. It means what? It means that so many processes are come. Means so many processes are come. It means what? So many processes are leave the CPU. Okay, so this is what the waiting time means process does not have to wait for the CPU. Process come, get a CPU and execute and terminate. So these things basically done very fast. So that's why average waiting time in HGF is basically very low, very minimum. Okay, this is the this is the algorithm which gives us a minimum average waiting time among all non-preemptive. Now, what happens if we see the preemptive algorithm as well? So, which scheduling algorithm will give us a minimum average waiting time among all the processes, among all all the process, among all algorithms? Now, if you see these things among all the algorithms, you say SGF, then you are wrong. The scheduling algorithm which gives us a minimum average waiting time is SRTF. SRTF is what? SRTF is basically an upgraded version of SGF. And SGF, what happens is if a process get a CPU, it will leave CPU when that process is completely when the process is complete, then that process will leave the CPU. But SRTF is what? SRTF is a primitive algorithm. Means if a process come in a CPU, this is what a CPU. If a process come in a CPU, let's say P1 process come in a CPU, if some other process, let's say P2 process have a higher priority than P1, but P1 is running on a CPU, P2 come and say that I am in a urgent, I am very important for the user. So what operating system do? Operating system collect this process and remove the currently running process in the CPU. Means P1 is now removed from a CPU and P2 will get the CPU. So these things happen. Okay, so SRTF is basically give us a minimum average waiting time among all the non-scheduling algorithm. Let's see this thing as well. Like we have a processes P1, P2, P3, and let's say that we have our burst time of the processes like 1, 2, 3. Okay, so in SRTF, what basically happen is let's say an arrival time of these processes are like 0, 1, and 2. Okay. Now, what happened is in a if we say see the SGF scheduling algorithm means P1 is the lowest burst time, so P1 will get a CPU, then P2, then P3. But if we talk about SRTF, then P1 get a CPU. If the burst time of P1 let's say 2, the burst time of P1 is let's say 2. So what happened is after P when let's say the burst time of P1 is what 3. Okay, but it come first, it get a CPU. It get a CPU. So gang chart will look like this. Like P1 will get a CPU, but at 1 it leave the CPU. Why it leave the CPU? Because at arrival time 1 we have one more process available which is P2. Now two processes in a ready queue. Two processes is in our ready queue. So whosoever have a smallest burst time will get the CPU, and is now the smallest burst time is of P2 process. So P2 will get a CPU. P1 have to leave the CPU. Okay. So the continuous switching is taking place rather than in Azure. What happens is one process get a CPU, execute it fully executed. When it complete, then only it leaves the queue. But this thing not happen in SRTF. That's why it gives some minimum average waiting times. Okay, so this is what the two basis of analysis. Now we are moving towards the next. The next analysis is that which scheduling algorithm will preemptive always means every time the process will not follow anytime the process will not follow a non-preemptive approach. So there is a algorithm. If you say round robin, if you say SRTF, if you say LRTF, if you say any non-preemptive any preemptive algorithm, then you have to think once again. Okay, why I said this thing? Because it says preemptive always. No scheduling algorithm will preemptive always. If you take an example of a round robin, what happens if the process is in a ready queue, let's say P1, P2, P3, the burst time of the process is like 2, 2, and 1, and the time quantum is what 3. So if these situation happen, then what you see that process P1 get a CPU execute completely, P2 get a CPU execute completely because the time quantum is what 3 and the burst time is what 2. So and P1 come and a P1 completely execute. So there is a no switching, there is no a repetition of a process. This is what happened in a preemptive algorithm. But if the situation is like this, then round robin will also follow a non-preemptive approach. Means process come and leave, never again come in a ready queue. Okay, so it's also a non-preemptive approach. So preemptive algorithm is also following a non-preemptive approach if some condition, some if there is some condition like that. Okay, so preemptive, no scheduling algorithm will preemptive always. Okay, this is a very important point. Now the next point is that non-preemptive always, non-preemptive always. The scheduling, there is a scheduling algorithm which non-preemptive always. So if you say no, then you have to think once more. Why? You have to think once again. Why? Because FCFS is never become a FCFS is never become a preemptive algorithm. Okay, so all non-preemptive algorithm will always a non-preemptive algorithm. It never become a preemptive algorithm. Okay, so FCFS, HGF, whatever the non-preemptive algorithm is always be a is always be a non-preemptive HRR and any non-preemptive algorithm. Non-preemptive. Any non-preemptive algorithm will always a non-preemptive algorithm. Okay. So this is what okay. So priority based algorithm is also come in a non-preemptive algorithm under some circumstances. Okay. So priority based algorithm is also come means the other process. Let's say the priority one. Let's say the P1, P2, P3 processes. Okay, now what happened is P1 come first in a CPU, priority is 1. P2 come CPU after P1 priority let's say 2, and then P3 priority let's say. What happened when a process come in a CPU but the priority is lesser than the whatever the process is in a ready queue? So definitely it also follow up. Now what happen is the process come first will get a CPU first because the priority of a late coming process is lower as compared to the already processes available in a ready queue. So now the behavior is looking similar like non-preemptive algorithm. Okay, so priority-based algorithm is also follow a non-preemptive. Okay, so this is what a basis of analysis. So we see four bases of analysis. Now we are fifth basis of algorithm is, will SRTF behave as SJF? Will SRTF behave as SJF? Think about it, pause the video, think about it, and then comment down your answer. Okay, so will SRTF behave as SJF? So the answer is yes, but there is a situation for this thing. Okay, so what is the situation? Situation like when all the processes arrive together, then SRTF will definitely behave as SGF, because SRTF is what, the upgraded version of SGF, the preemptive version of SGF. What happens is we have a process, let's say P1, P2 and P3. The burst time is like 5, 4 and 3. But what happened is it all arrive at 0. Arrival time is what? 0. Now if this situation occur, then what SRTF do? We have to solve this with SRTF. Now what happened? Simple. The SRTF will follow a SGF rule. Whosoever have a smallest burst time will get a CPU, means P3 get a CPU, then P2, then P1. And if we see, if we solve this with SGF scheduling algorithm, we also do the same thing. We select P3 first because of a burst time, then P2, then P1. So it means what? SRTF behave as SJF when all the processes come at the same time. All the processes come in a ready queue at a same time. So when all the process arrive together, when all the processes arrive together. So then we can say that SRTF behave as SGF. Now then what is the next part? There are something else situation as well to that SRTF behave as SGF. So yes, the answer is yes. What are the situation? When the later arriving process are not smaller than the running process. What does this mean? Let's say we have a process like P1, P2 and P3. Burst time arrived. Let's say P1 come first, then P2, then P3. So this is what a situation is look like. P1 come first, then P2, then P3. The burst time of P1 is what 2. The burst time of P2 is what 8, and the burst time of P3 was 16. Now what happened? P1 get a CPU first, then P2, then P3. Why I say this? Because our next arriving process is having a burst time greater than the currently running process. Okay, 8 is greater than 2. So definitely the operating system choose P1 firstly to execute, and then P2 and then P3. So when the late arriving process come with a great burst time, with a huge burst time as compared to the running process, then we can say that as then we can see that SRTF is behave as SJF. Right? So these are the two situations when SRTF behave as SJF. Okay. So when late arriving processes when late arriving processing are not smaller than current running processes, then we can say that SRTF behave as SGF. Now, what is the next basis of scheduling algorithm? That preemptive priority based algorithm behave as a non-preemptive way. Preemptive algorithm, preemptive algorithm behave as non-preemptive. Now think about it. Pause the video, think about that, and comment down your answer. So if your answer is yes, then it's true. It's true. Why I say this? Here is the example as well when it behave as non-preemptive. We discussed a few minutes before. Okay. So now, what are the points that when the priority algorithm behaves as a non-preemptive way. Preemptive algorithm behave as a non-preemptive way. So when all the processes arrive together, okay, the same thing which I told you that we discussed right now a couple of minutes before basically. Okay, so when all the processes come at a same time, then we can see that SRTF is what? SRTF is a preemptive algorithm, no? Okay, so it behaves as a non-preemptive way when all the processes come together. Similarly, preemptive algorithm behaves as a non-preemptive way when all the arrival times, when all the processes come at a same arrival time. Okay, all the process arrive together when all the process arrive together. Now, what is the next point? There is any other thing as well? So answer is yes. When the later arriving process have a lowest priority. Okay, so preemptive priority I can preemptive priority. Okay, so when all the processes arrive together, and the next is when the late arriving process have a lowest priority. When late arriving process have lowest priority. Late arriving process have a lowest priority. What does this mean? This means that let's say we have a process is P1, P2 and P3. The burst time is like 2, 2, 2. But P1 come first, P2 come first and P3 come first. Okay. So this is what a situation is look like. 1, 2, 3. This is what an arrival time. This is what a burst. But P1 having the highest priority. Let's say 1 is determined the highest priority. P2 have a lowest priority. 2 means smaller than the previous one, and the 3 means the lowest one. Okay, what happened if the late arriving process have a lowest priority, then also the preemptive priority algorithm behave as a non-preemptive way. Preemptive priority algorithm behave as a non-preemptive way. If the late coming process have a lowest priority. So this is this is what a basis of the basis of analysis of an algorithms. There are a few more. Let's discuss these as well. Now the next is now we talk about a lot of preemptive, non-preemptive these things. Now we particularly talk about a algorithm like will RR behave as a non-preemptive? RR behave as a non-preemptive. What's your opinion? Pause the video and comment down your answer. So if your answer is no, okay, so it means you are not understand the round robin scheduling algorithm in a bad way. So the answer is yes, it can behave as a non-preemptive way when I told you earlier as well when the late coming processes, this is what I told you, when the late coming process have when all the process basically the burst time of a process is smaller than the time quantum, then SRR will behave as a non-preemptive way. Okay, so answer is yes when the burst time of all the processes when burst time of all processes is less than or you can say equal to less than or equal to the time quantum. Q is what? Q is a time quantum. Okay, so RR will also behave as a non-preemptive. Now what's the next thing? Next thing is now we discuss about all the algorithms, preemptive, non-preemptive, okay, different things. Now we see now we see the different thing like which process basically follow a convoy effect, which process will have a convoy effect. What's your answer? So the processes to follow the convoy effect is first come first serve. Definitely, if you see my algorithm videos, then you understand that which algorithm basically follow a convoy effect. Longest job path will also follow convoy effect. LRTF will also follow convoy effect. Okay, so these are the algorithms which follow a convoy effect, which basically have a convoy effect. When convoy effect is what? When the huge process come and get the CPU and the smallest burst time process will not get the CPU for an undefined amount of a time or for a very long time. then we can say that that process will come in a conway. That process will basically a conway. That algorithm is basically a conway. Okay. So these things follow in FCFS, LJF, largest job first and largest remaining time first during algorithm. Okay. Now after that conway effect, we discuss conway effect, then we have to discuss the starvation as well. So starvation means, what is starvation basically? First of all, starvation means process never get a CPU. Okay, so this means starvation. So which follow the starvation? So SGF follow starvation. How SGF follow starvation? And we see that SGF give us a minimum average waiting time, means there is continuous switching of a process taking place in SGF. Then how starvation is possible? Because if the very high bus time process is in a ready queue, so and the continuously switching between a small bus time process taking place, then the largest bus time process will never get a CPU. Let's take an example like P1, P2 and P3. The bus time process of P1 is what 1, P2 is 2 and P3 is 12, and there is a continuous P1 come in a CPU, execute, terminate, and then at a time P5 process come in a CPU, bus time is also 1. Okay. After that P2 complete, then there is a process P6 come in a CPU. So there is a continuous switching between the two spots. So the P3 process will never get a CPU. P3 process never get a CPU. So if P3 never get a CPU, then it means it goes in a starvation. It never go in a conway effect. Conway effect means the big process get a CPU. Okay, starvation means the process never get a CPU. There is a difference between these two terms. Okay, conway effect and the starvation. And if SGF, then SRTF as well. SRTF and the big algorithm, the priority based algorithm. Okay, definitely priority based algorithm will process basically come in a starvation in a priority based algorithm. Priority algorithm. Uh, and that priority algorithm, priority is basically of two types, preemptive and a non-preemptive. So we can write both for both. And L largest, LGF largest of first. If LGF, then LRTF as well, and many more algorithms, which basically starvation taking place. But these are the primary examples of starvation. Okay. Now the last point for the basis of an algorithm, which is that when LRTF is a non-preemptive algorithm, will or when it will, or you can say when LRTF is non-preemptive. Now, LRTF, we know that LRTF is a preemptive based algorithm. Will it follow a non-preemptive approach? So the answer is yes. When all the process have a burst time, basically one, then definitely we can say that LRTF will follow a non-preemptive approach. LRTF means the very big process get a CPU first. Huge burst time process get a CPU first. Let's say P1, P2 and P3. The burst time of P1 is what 100, P2 is what 100, P3 is what 200. So 200 will get a first, then P1 and then P2. So these things happen. Okay. In this way, the LRTF basically performs huge burst time process get a CPU first. Okay, it's a not practicable approach, not a real life example of this particular approach, but it can behave as a non-preemptive way when all the process have a burst time one. All the process have a burst time one. Okay, so when all the processes have burst time is equal to one. All the process have a burst time equal to one. So this is an example of this is basically a situation where RRTF is behaved as a non-preemptive way. Okay, so I hope okay. So we discuss all the analysis that what basic which algorithm follow which thing. Okay, and this is what an analysis of an algorithm. Okay, I hope you like the video. You understand so many things about the algorithm. Okay, so thanks for watching this video. Like the video and subscribe my channel.